making an exception this time. Pretty slides, and there's a good reason for that. So, Tavis, Roman, got a background mostly Python, R, a couple functional languages, a lot. Lots of different styles, and use anything that goes. Roman?
Me, on my part, I have been more of a functional whore. Always liked Haskell since 2006, and I wanted to go into that branch as much as I could, and with Tavis working in Birdseye software, we have done that, and it's pretty cool.
Okay, load this URL, preferably over 3G, not over the Hive guest network, because we don't want to flood ours. We'll pull it up, and it's going to ask you to log in. Just go ahead and do that. If you're being lazy and just sitting there, get your phone out and do it. This is our load test.
Oh.
Okay, throw your hand up once you're on the intro slide. They're slow.
What should it show?
You should get to a login page immediately, and then it'll go to the very first of the slides you saw before.
Log in?
Beatboxing Mario. Yeah, log in. Good choice.
It's slow, man. This is Node.
Yeah, we use Node for the back end just to troll this guy. He's got plenty of hate if you need any.
That's what I'm good at.
Okay, hands up if you're in. Fail? What failed? OAuth or?
Yeah, I guess so. Failed to find request token in session.
Try logging in through a different provider then. Which one were you using?
Twitter.
Twitter is kind of flaky.
Yeah.
It wasn't testing last night, so. GitHub seems to be reasonably reliable. Google as well. Just put your hands up once you're onto the slide that looks. It's got Mario. Yeah, it's the beatboxing guy. Okay, Yuri, you should be seeing this one now. You're still on that.
Actually, well, like I thought it was loading, but it's stuck somewhere.
Alright. Keep trying this URL. We're not going to pause here and wait all night while people log in, but the slideshow here is actually the demo software. We've used the techniques we're going to be talking about to do the slideshow presentation system, and it's got the ability to have slaves, an audience of slaves. We can take control of your device and make it do evil things.
Yeah.
So we're going to do
curl
that.
too.
What's that?
I'm timing out on curl too to the main page. So.
Alright.
So
Okay, so more on that later. See if the Hive network is still going here. Okay, so the stuff we're going to talk about tonight was inspired by a project we worked on last year, a very complicated dental, like fake teeth prescription system. There's like 27 trillion possible combinations that you can enter on this form. Really, really complicated, too big to talk about here, but the techniques that we're going to talk about are very simplified, dumbed down way here, and used in the slide presentation stuff. We use for developing and testing this. So, our goal is to kill Mr. Spaghetti Code here. But how the hell do you do that? We've got a four-step plan. Specifically, how do you kill Mr. Spaghetti Code on client-side UI, single-page JavaScript apps, and so on? First step of the plan is to do what anyone who's modern should have done anyway. If you're using any of the identity star frameworks, separate the model from the view. Obvious, boring. But which freaking one do you choose? Hands up for backbone. Knockout. Angular. Ember. Hands up for people who have switched at least 2 times. Yeah, I thought so. Okay, so assuming that you've settled on a framework and you've solved the first problem in the 4-step plan, you've got remaining problems. You're tightly, in most cases, you're coupling yourself to the framework. The way the framework wants to do things, the subclasses it wants you to use. And if you're not careful about it, you can get it into the same sort of callback and binding hell that you would have had prior to moving to a big framework. And you might have solved the problem of taking your state out of the DOM and keeping it to simplified, plain old JavaScript object models. But you've still got the issue of handling the loop, user interactions, updating the model, updating the view from the model, and so on. And testing is still kind of painful, lots of mocking and fixtures required. So step 2, and this is part of the philosophy we're going to be espousing here, is move away from having a model that uses mutatable methods on mutatable models. What the hell do I mean by that? Anyone lost at this point? By that phrase? Nodding heads? It basically means having objects which are mutating throughout the course of your user interactions. Sharing a reference to some sort of memory object which you're, every time a user does something, you're munging its data, munging its state, doing something in a way that destroys the history of what it was before. And we're advocating that you should be moving towards explicit domain events where you would have had a method name and a method call. You have a record now, just a JavaScript object, which represents what the user wanted the software to do. In the context of our slide software, forward, next, back, up. It's got up and down support in reveal.js, which we're using for the pretty side of the slideshow here. Pause. Overview mode. Oops. What the hell happened there?
Command Shift T.
Apple what?
Shift T. Shift T.
Apple Shift T. No, that's the wrong one.
No.
No, this is the test one.
Oh, crap. Oh, there's connecting.
But we can use this one anyway. Okay, so domain events to explicitly represent user intent. What should happen to the domain model? And then instead of having a domain model made up of objects that you're mutating and changing over time, you've got a series of explicit states and records, simple JavaScript objects that represent each one of those states. And we'll show some more detail about what the hell that means. Step 3, we want to go from UI bindings that talk to the model code directly and invoke method calls on the model objects to UI event bindings like jQuery.bind or whatever you're using to, or even the simple stuff that's built into the DOM to grab the user's interactions. And instead of calling stuff directly on the domain model, you publish domain events over sort of an in-process pub/sub channel. We'll explain that a bit later. So you translate UI to domain events. final step is you react to those events and update your domain state. So in summary, you can actually see all that. You've got UI events at the top there, some sort of binding mechanism, creating a domain event stream, and that's like a pub sub channel in process, to a function or some part of the domain code which calculates the new state from the previous state plus the event that just happened. And Roman's going to explain that in a bit more detail for people who haven't done stuff like this before. So you get a new state, and then you publish it to the view updater, which does whatever's needed to update the DOM. Okay, so.
Okay, so I'm gonna explain how does the managing the state out of events work. So we're gonna go with state reduction 101, and this comes from functional programming. It has many names. You probably have heard it, have seen it in the language you're working with. Reduce in Ruby, inject is in Ruby, reduce in JavaScript or Python, and fold out in Haskell. And this is more or less how it works. You have a function where you have a result and an element you want to apply to the result that is carried so far. And the JavaScript example here is the best one. You have a list of numbers and you just want to add it. So you have the add function that just sums to numbers. And in reality, reduce does exactly what the arrow over here is showing. It's just putting the operator in between every element. That's one way to see reduce, inject. In reality, though, it's doing an associative sum, like the one that is below. So it's important to know the associative property of the function you're using on the reduce parameter. Another way to understand it is by this cute example that we found over the internet. The link of the credits is down there. We can't see it.
Yeah.
So imagine you have this array, the same array we were showing so far. As soon as we want to fold from the left, we sum the number of
Mic down a little bit. Second.
Yeah. We put the number on the left. Better?
Yeah.
The number on the left plus the number on the right. Or the operator in this case is plus, that's why it's plus. So you get 3 as the result of that operation. And then you continue folding over. So in this case, the next step is going to be 6. And then and the fifth operation is just going to be 15. If you keep summing the left value with the right value. And that way you go reducing over all the list. And at one point, you just get the final value with the sum. So this is how fold L works, or reduce, or whatever you want to call it. The same principle can be used for getting a state of your application from a group of events that have happened over it. In this particular example, we have a state that is just represented as a JavaScript object. And we have the reduce function, which is going to get the previous state and the event that happened and create a new state out of that. So in this case, we are checking that the domain event, in this case, is a move event. Depending on what it is, we're going to modify the state as it goes. But we are not going to modify the instance we have, the previous state, but rather we're going to clone it and create a new state out of it. That means that the previous state is not affected at all. In JavaScript, it doesn't make too much sense because there's no multi-threading, but most other languages it works like that for multi-threading reasons. We see down below an example of what happens when we apply reduce with a group of events, the reduce location state and the initial state, which is x0 and y0, and that's the result we get. Of course, in the middle of the process, we're going to get a lot of states for each of the events applied. At the end, the state of your whole application is just a reduction of events. So you don't have to rely on the current event, or you don't have to be worried that an event is gonna, like a state is gonna be corrupted anyway, and you're not gonna be able to recover because your source of truth are the events, and you can create a state from that.
So we can say that event source, that's basically event source in layman words. We can say that event source is event driven plus a little bit more. Having an event driven architecture is a prerequisite, but it also adds the event as part of the history, and you are able to recover your current state from the events. And the current state is derived from that. So I think the next, yeah, like it's also possible to have an object-oriented programming. People from .NET has used this approach a lot with object-oriented programming. Google that.
We should also, Greg, are you sitting back there somewhere? This guy's got a ton of good videos on this sort of shit. So Google for Greg Young, his videos on InfoQ. If you haven't seen them already, they're well worth watching.
Oh yeah. So, back to you.
Okay. Okay, so first off, apologies to Cliff, who was asking about how to use event sourcing server-side in his project. Sorry, we're not going to talk about that, but lots of other people have. You can go back to that Google search and look for benefits. There's a ton of them. Audit trail being an essential one in many domains, accounting. In the domain that I've worked in most, medical records, you need to have audit history of what's being changed, who's had access to data, and so on. We're going to focus mostly on the rest of them. Event replication, testing, and deriving additional business value from the event stream once you have it. There's definitely a cost to doing things this way, but these are the payout that you get. So this guy here knows a shitload of actors. Jeremy, Aka, the stuff they will talk to you about nonstop over beer. Same thing, different words. In fact, the Erlang examples are probably very, very similar in spirit, at least. So what about the client side? Given that we understand what event sourcing is now, and a very simple explanation from a functional language background, we're going to focus on how to use it to do a style of UI development called reactive programming. And hoping to have everyone online doing this, but you want to?
I'm on. Yeah.
Okay, is it following along when you do this?
No, I'm following it.
You're on your test VM still.
Yeah, you're
Oh,
on
yes, I am. Let me just pull up the.
It's the last step.
It's the last time I have.
Oh yeah. Okay, so I'm just gonna jump ahead. Okay, so slides demo, went past it.
Slides in. That one.
That one. Okay, so you're gonna notice here, if you're one of the slaves out in the audience, if you on your phone swipe back and forward, you've got your own state history. I'm overwriting it every time I make a slide advance up here. But if you swipe again, your history is still there. It knows where you were. And in fact, we're persisting everything that anyone in this audience and what I do up here to a Redis backend, and we'll have the full history of who did what during the talk. And by the way, if you want to ask questions,
Yeah, you can ask me too.
no, remember the feature.
Oh yeah, double click.
Double click any slide, and it'll queue a question. Okay, so going back to slides demo, we wanted something to look pretty like Reveal.js. And we were sitting down last week thinking, okay, how are we going to do this talk? How are we going to show off the benefits of doing things in this reactive event source, event-driven way? And we thought, screw it, let's make our slide software the demo itself. Self-recursion is awesome. So the starting point was Reveal.js. If you've got your copy open, just click on the link and you pull up the source code for what it was originally before we started fucking with it. So it's one big 2,000, close to 2,000 lines, 1,500 line JavaScript file where the state is stored in the DOM The event bindings are mixed right in with all the state updates. There's no notion of layering of concerns and separation of concerns. It's all together. But it looks beautiful, it works, so we just hijacked it. And what we've done is skip right past using any of those MV star motherfucker presentation, sorry, MV star frameworks. But screw it, we'll just do it ourselves, but piggyback on top of two awesome libraries. So the first one, stick up your hands if you've heard of it. So reactive extensions, or you may have heard of the .NET version of it. Reactive extensions from Microsoft. Hands up. All right, there's a JavaScript version. It's open source, Apache license. It's up on GitHub. It's installable through Node's npm package installer. It's a little bit large. It's like 30K uncompressed, but it's awesome. And apparently Greg's got even more awesome stuff related to this that he's going to talk about later over beer. So it's a library that allows you to do reactive programming where you have these event sources, and then the reactive framework lingo, those are observables, and then you have observers observing any events that are coming out of those observables. So it's sort of like flipping the iterator pattern around. Or if you think of Unix pipes, pipe shit in, process it, get stuff out. PubSub, Rabbit, Redis PubSub, named pipes even. Same sort of principle where you've got a pipe of some sort of stuff going in and consumers on the far end doing something with it when they're called. It's push driven. Fay, hands up for people who've heard of Fay. 1, 2, 3. How about Sock.io? Alright, same sort of thing, but PubSub layer, simplified on top. Alright. So I should just mention that RX, if you have ever used or looked at Link, Microsoft, the same guy, the same team, they created that, came up with this. I've never used any Microsoft products, I should make that clear in like last decade, but I love this shit. Okay, so pipes. In RxJS lingo, they're observables, and we'll show you some examples of how those are actually used in the code later. Fay, it's channels. How many people, oops, how many people here have done any sort of server-side PubSub stuff? A lot, okay. Hopefully some of this is familiar. I think I have the diagram on this version. So same old diagram again. Where it says PubSub, we're going to inject rx.js.
Here.
Let's see if we can get this open. So if you're following along, these links in the slides now go to GitHub and show the code. Zoom in. So, the events that we were about when we were presenting the slide deck is select, toggle, and you can read the rest. The first line has this is CoffeeScript rather than JavaScript, by the way. How many people here think they can read it or can read it? The rest of you just follow along. The nulls are just empty constructors where down below here we created a default constructor for them. And these arrows, if you haven't used CoffeeScript before, like anonymous functions. Instead of typing FN, you just type arrow. So, back to here. We have the events from the DOM. Being captured. We've got touch events here on the phones, iPads, and so on. Key bindings for these guys, and we're converting them, like in this line 113 here, from the UI event into the domain event, and they're just JavaScript objects. If I was to construct one of these things in the Firebug terminal, just print out constructor with no state inside of it. Sorry, no member variables or anything in it. There's only a few here that actually do have parameters, like the ID, the horizontal and vertical index of where the slide is in the slideshow. So, this last line here is filtering out any nulls for any gestures or click events that don't actually map into one of the domain events. So this wires it up, and it's implicitly returned from the end of this function, and we use that elsewhere. Over here. Everyone get ready for that? So the same function we were looking at before, we wire it up. And then we're subscribing, basically passing in a callback that's going to be called every time there's a new event on that screen. You click something, you touch something, you get a domain event out of it, even though it's triggered by the UI. And then we're republishing it to this local slide event string. We're just having a layer of decoupling there so we can synthetically fire in UI events as well. And then this bit here, aggregate is just another word for reduce, inject, and we start with an initial state. Oh, you're going to say something?
No, like, I was going to say something in the previous slide, but it's all right.
Okay, so we load up the initial state, and you're going to have to wade through the code to understand how everything is bootstrapped up. But you've got an initial presentation slide state. It says which slide we're on, is it paused, are we in overview mode, and then this aggregate state on slide event function up here is pretty simple if you take away the error handling. You get the new state by calling this function from the core domain module. It, without any side effects, just returns a new state record without mutating the old state or the event. And then we just publish that. So we call a code that has a side effect of the DOM. This update reveal for presentation state. I think it's actually on our next slide. I'll skip past this and go to this one. So state records that are coming from that aggregator, state production, are passed into this, and it does all the weird DOM manipulation stuff to update the actual thing you're receiving on the screen. So I'm going to back up a couple slides here. Saw that. Core concepts of our domain, and you notice there's no framework code in here at all. You're not subclassing anything. You're just constructing objects and passing them around. You never change any object once you've created it, just plain old data. Just like you never change the bytes that came in on the input standard in on a Unix pipe. They're in the past, you can't change them. A couple functions for calculating things based on the domain, how to move to the next slide, up, down, previous, next, and so on. The events that you saw before. And the key thing that we were just looking at is the notion of what the presentation state is. Which slide you're on, which mode you're in, normal overview, is it paused? The rest of it is just a collection of event handlers, what to do when each one of these events happen. And I'm just doing a partial, you'll notice that they're only returning a couple elements that have changed in the state record here. Like enter full screen only says full screen true. It returns a JavaScript object that has that and nothing else in it. And down below, it's like a div on the object. Down below, we're cloning the previous state first, and then extending it with what changed, applying the div to it. Roman, maybe you want to talk for a second here about some of the performance freaks. Cliff, where are you? In the room, we're probably thinking with all this cloning and copying objects.
Well, yeah, like this is the naive way to do it, and well, in a language like Haskell or Clojure or Erlang, you will have what they call persistent data structures, where basically you are changing attributes of a immutable object, but you're not repeating the whole object in memory again, but rather just from a special data structure, you are just putting the new values of the record together with the previous one that haven't changed. So that way you can store, like you can reduce the usage of memory a lot. In JavaScript, of course, this is not the case. There are some libraries out there that might help us, but we haven't played with those. ClojureScript does it, but it's only on ClojureScript. Like
yeah, the ClojureScript's all these scary parentheses that we don't want to throw at you tonight. We love it, but we didn't think you would.
And yeah, like this has a performance penalty for sure on memory size.
But for Christ's sake, it's a slideshow.
Yeah.
Does it really matter?
Okay.
But there's one objection that people will throw up over and over again when people start talking about event sourcing and immutable domain models. And there's another one which, when we get to questions, I'll be very surprised if it doesn't come up, but we'll wait. So, again, no framework in your domain code. Pure domain code, simple little functions that are easy to compose. If you want to swap out the framework you're using for doing the UI stuff, like we're using jQuery for the tiny little bits of binding we're doing, but we're not bound to it. We want to swap it for something else, or just do the plain old functions that are built into the DOM. We're okay to do that. We don't have subclasses underlying everything that are preventing us from moving away. So, immutable state records, we said. This is the diagram that we are showing. This one. If you want to see this one again, look at it on your computers by yourself afterwards. We'll publish a link to the slides. In summary, UI events in a linear fashion go down into a domain event stream. They're published over a pub/sub channel. You do your state production, output your new state from the production of the event and the previous state. You get your new state, pass it to something that updates the view, and circle around again. So there's a very straight linear flow to all the stuff you have to worry about. Rx.js has some other convolutions it does internally, but from a what is my code doing perspective, it's linear.
If you want me, I can go a little bit more about the bind process because I think it wasn't that clear.
Yeah.
Can you go to slide where you have the event domains?
Yeah. The model code?
Yeah, the one with the events. That's the one.
You want this one?
Yeah,
Yeah.
actually that's the one I want. So you can see that at this point we're using jQuery and we are selecting the body. This bind is observable. What it's doing is basically doing the same thing you will do with a key op in jQuery, but it's returned as an observable. An observable in Rx.js is just imagine it as a queue where you subscribe to, and you can get all the events from this queue. But at the same time, you can transform them, as we are doing in here. If you see the key ops, how we're using it down there, you do .select, and we are using this function to transform the key ops events into slide events, domain events, and we continue passing that through. So at this point, we are not consuming them, we are just transforming them for a consumer later on.
Maybe mention merge as well.
Yeah, and the other important thing is that using this approach, we don't only got away with handling the UI events, but rather we can also handle remote events. Well, in this case, it's not remote events, but we are getting events from a bunch of different places, and we are putting them all together in just one channel. So whenever you're listening to this channel, you're just going to mutate the state the same way you're doing it if you were listening from a, if you were listening from a key-op or from a touch event. The advantage of this is that later on we can not just merge it to the local UI, but rather to our remote machine. And that's exactly what we're doing and how slaves are working. We are just publishing the events that are happening on Tavis computer and passing it over, and at some point merging it into this stream. And your computer believes it's the local UI, but it's not.
Which reminds me to ask, how many people here have like a laptop and a phone? Several devices. Log in with the same OAuth credentials that you logged into the slideshow with, and you'll see that it actually merges your event streams. Your own private event streams. It won't. You can't throw porn on our screen, but
yeah. So I think that's a really important thing to digest. The fact that you're abstracting, doesn't matter where the event comes from, transform it to the domain event so that you can talk towards those specific events rather than a specific host or clients, and use that to change the state of your application. I think that was a really important point.
yeah. In fact, here you can see that after we do the state reduction, we got a new state. We create this record that has the previous state, the event that happened, and the new state. And we piped it into this channel, this event stream, local slide state change, and we subscribe to that separately down here. First of all, we're logging it to the Firebug console, and we're also logging it remotely to the server. And then we're filtering on any remote events that have come in. We don't want to get in a sort of republish loop. Like Vincent, you're doing right away. So his remote events, when they get replayed on his laptop, from his phone to his laptop, they come in and are marked as is remote. And it knows not to republish those onto the network afterwards. And the publish slide state change is also on the server side sticking into Redis. So should you need to, it's kind of our, in this example it's kind of contrived, but if you have some complex UI, for example, like this prescription thing, there's lots of stateful interactions here. I'm adding a new part to this prescription here. There's lots of little modal bits and pieces I can click on, get into states, possibly get trapped in a state that I can't get back out of. With the ability to publish the event stream as it happens and have all the timings and even the DOM nodes in screen coordinates that they clicked on, you've got, if you want, the full history of what the user did and how the state changed on this particular OS, on this particular browser, as a result of what they did. If you're resisting it, like we are for the slideshow, you've got the ability to replay that later. And that's where the event sourcing bit of this comes in. You can replay it, see you've got a bug report, user did such and such, and the system did something that it wasn't supposed to. And they're on iOS something or other, and they're using the Chrome browser on it. You can load up their history through a service-like browser stack where you get a fake browser in the cloud that emulates, or maybe it's the real browser that they were using. And you can get back to the exact point where they said something went wrong in the same event history that they generated. And we found that extremely useful for the prescription work we're doing. We have weird CSS glitches that would only show up in one place, but you have to click about 20 things to get to it. And have the ability to, let's see if I see this here. I'm reloading, I don't know if the network's actually going to work on this, but I'm reloading something that populates every single one of those teeth to see how the UI, I think it's going to work. Anyway, you can have saved histories, reload them later in a different spot. which has obvious benefits as well for testing. If you have events that can be captured and replayed remotely, you can use what users have actually done to do your regression testing. Say that you've got some sort of UI that you can model like a state machine, and you've got known transitions, and you get to a particular state where these transitions, these events shouldn't happen at all. You can do something known as generative testing to generate synthetic events against the current state. Aside from you, who's used Quick Check or anything like it? Anyone care to give a someone? Stand up and say what Quick Check is very briefly.
Well, Quick Check is basically a tool where you can generate input for functions. When it automatically reduces your input to the smallest input that fails. You can basically use, you can say I want to use a generator that generates input just given its type, and Quick Check generates objects or instances of this type and feeds it into your test, and your test checks versus precondition, post-condition. If the test fails, this way it excludes certain inputs that are invalid, and basically you can use properties on the code to rapidly find what is correct and what is not correct.
Yeah. So it came from Haskell, I think, originally.
I would actually, like, for the sake of simplicity of the explanation, I would say, well, when you're writing like normal tests, what you have, you're writing specific test cases in your tests. But what you do with Quick Check kind of approach, you write a program that generates those test cases massively, going over different parts of your data and logic. So you're just getting more cases out of it.
Yeah, if you think of a function or a state machine that has a known range of inputs, the domain of the function, you can do a random sample across the entire thing, find edge cases that you'd never think of typing in yourself. And for this one here, we've got trillions of possible prescription combinations, and you can combine them in different ways on this UI and put them together in different order. Way too many fixtures to manually type in, or even collect from user input. So we just generated them. And we did the same thing for the event sequence. We've got states, known events that can happen to the domain from there, just generate them and run your test from that. Sort of related to state machines as well, it's really simple to, when you've got an abstract code totally detached away from anything to do with state management and the view code. It's easier to think about and model the scenarios that you might want to represent in your software. And if you want to get really fancy, and we've just hand-waved about doing this, but you could use a Prolog type approach, or logic programming approach, where you put together sort of Prolog rules or logic rules, sort of facts, in your logic database and say, okay, find me any invalid states I can reach, any states that are dead ends. Or say that you've got a starting point and an end point, validate that through the state machine I can get to the end point. If the user starts creating a prescription, can they actually, using the code as it's written, can they actually get to the end point? I'd love to see someone who's done that sort of stuff combined with this idea. Okay, now the fun bit. You get some free superpowers for this. Sort of alluded to a few of them already. So the first one, time travel. If you do things this way, you've got history and undo for free. You've even got bug undo. You release some software. This is more the server-side aspect of it. You release some software that has a bug in it, and it's corrupting the states. But so long as you've got the full event history, and you're logging all the transitions, you might be able to recover it. People who love doing this on the server side talk about this all the time. Yeah.
The second one is jump through wormholes. where you can actually go to different places like you're doing right now with your slaves, and like being able to put your same data into a new context completely and replicate it there. That's by having the events, you just have to cheat the other client saying, hey, this is me, just repeat these events, and you're just moving it around, and the client code doesn't need to know where it comes from. That's really good and pretty awesome. The third one will be,
Oh yeah. So sort of like Vince is doing right here, you can be in multiple places at once. You can have multiple devices you're interacting with, and you're updating the state on all of them. So the slideshow presentation, that's exactly what it's doing. By the way, remember, if you want to queue up questions, double click or tap twice on the slides. So this one here,
visit parallel universes. You might get different versions of the same data and get the awesome part is that from the same source of truth, you can get so much data that is different. You just have to change the reduction function. And you can start checking out the statistical data of your events. Say, in this specific scenario of the slideshows, we can start seeing how much time you spend on each of the slides. And we can do some statistical analysis and see which one you take the most time to read. And probably that's because it was harder to understand, or you can get insights out of the data, even insights that you're not aware of. A lot of time happens that you say you want to add a feature to your application, and you say, oh, but we need to collect data in order to know for sure what's going on in there. And you say, okay, we're going to collect data from 1 month, and we will see that. With stored events, it's already there. You just have to reduce your events again with a new reducer, and you get new insights of data, a new universe of data.
yeah. X-ray vision. So it's a little bit hand-wavy, but I would argue, and I think a lot of people who have done things this way would argue, that you get a more declarative style of programming the core domain model. And you focus on the user interactions and how those relate to the domain events that are happening. And it's very obvious if your domain doesn't match what you're expecting the users to do, or vice versa, you should be able to see that. It gives you X-ray vision to spot those things where there's a mismatch. Focus a little on how.
And the last one will be hold your breath, basically. With storing all the events and being able to replicate it later on in another spot, you are able to actually offline the same way Git is. And replicate all those events you have done on the server later on. Of course, you will have to work with some synchronization issues, but that's manageable. So yeah. Conclusion? We think it's a pretty awesome approach to use, and it has a lot of benefits. Of course, we're not going to use this as a hammer for every single nail there is out there. But it's a really good tool in your tool chain for sure.
Yeah, you pay a price, a different price than what you would pay from doing other approaches, but I found it to be extremely useful. So, questions? Great.
You know, I'm a pretty big advocate of some of these ideas, but right there at the end where we were talking about having many offline places, and we've got this small problem of synchronization. We'd like to go a little bit more into that.
Small.
It's not exactly a small problem.
While we're doing this, you want to pull up the history of the question for us?
Sure.
Hopefully we can get that. So it really depends on your domain. There was a talk by, how many people know the name Brian Sullivan? Haskell guy wrote, one of the co-authors of Real World Haskell. You give a talk, some conference somewhere, a couple of years back, and someone asked him that sort of question, or maybe it was in his slides. And he basically brought up the point that if you have an additive domain model, you're always just adding new stuff to it. probably not going to have too much problem synchronizing events, and things that happen out of order you can recover. But there's a ton of domain models where that's not the case. For the synchronization between Vince's two devices there, if there were drop messages, no problem. We just take the last one and update the state, and then resynchronize where he was before replaying the event that came in case it was missed. You obviously can't do that with accounting. A transaction, you can't just drop it on the floor. So there's the issue with durability of the message channels that you're using, and guarantees of delivery, guarantees of ordering, and a ton of nasty little problems you get into when you start dealing with distribution of the events. But if you're lucky, you can get away with it. Yeah?
It's actually not always about luck. There are actually ways to do distributed and disconnected causality and ordering. So things like interval tree clocks, you can actually do lots of funny stuff with that. It's subject for another talk, I guess.
Yeah, there's a lot of academic papers that you can read about various algorithms for conflict detection and possibly resolution. Google's piped out a whole bunch of them about their in-house tools. Too much detail, but key thing is it doesn't work for every domain, but for quite a few domains it's reasonably simple. So,
when you're talking about undo and redo, are your events reversible, or are you going back in time and playing forward?
Either or. So you can have reversible events. In the accounting domain, we just add a new transaction that clears out the effect of the previous one. Okay. In other cases where, say for example, you're just seeing what user interactions were done and trying to understand how users are really using the software. If you get an event stream for what they did on the UI, it's very easy to put together a little slide dragger UI that will, as you move your slide back and forth, and you've probably seen Rec Victor videos of doing fancy stuff like this, you can just see, okay, what was the state at this time, and see like how many people know the function scan or scan left from a functional background, or reductions is another word for it. How many? It's a way of seeing what the intermediate states were after each reduction step. If you've got your history, you can see that. In terms of domain models that's useful for, aside from development and testing, it's got to be something. All right, so Roman's pulling up the list, but just keep on firing your hands up.
Might be a kind of naive observation, but it seems like there could be some really useful applications for user testing for doing this in certain, like your website with the dental, where there's trillion combination. You can really, I don't know if this is actually something you guys have used it for or thought of it, or if it's just a stupid way, but you can see exactly how users are interacting with things after interacting with another thing. You have this kind of really rich history.
You've got timestamps as well. So if there's like a 3-minute lag between last event and they finally figure out how to do the next one, you've got that information. Or if there is a domain where there's undo, I wonder if Adobe's ever done this with tools like Photoshop or Illustrator. Like data collection on how often undo and redo are used. Actions that frequently are erroneous that the UI leads them into doing. Lots of data mining for UI design.
There's a lot of online video games now will actually track the state of, like, you and like 3 other people playing. They'll track the entire state, and if it's like an FPS or something like that, they know where every bullet was fired from, and if you turn, they know how fast you turn.
Yeah. Okay, before Parvino, I was just going to say fraud detection. That's another obvious one. If you get the full event stream. Yeah.
So, a lot of this stuff was invented like a decade ago by the video game guys.
I would go you one better and say it was invented like 50 years ago.
Yeah, exactly. Like people actually used it, not academics.
Yeah.
So the seminal papers were 10,000 archers on a 28.k modem. That was from the Age of Empires guys. So they were actually the first to do like 8-player RTS multiplayer with tons and tons of things stimulating.
Yeah.
And you can do like replay, observer mode, all this stuff. Other seminal paper was lag compensation with frame interpolation. It was by the Steam guys, the original Source engine, where they did like multiplayer for Half-Life, I guess. And previous to that was Michael Abrash's papers on the Quake networking model, and like all of those 3 models are like very similar to like all this kind of stuff. So you have, so it's like how you have key up and stuff like that. That's exactly like how like your mouse and keyboard works in a video game. And replay, like imagine that and then how you go into replay mode, exactly how it works. So like there's like a ton of stuff done in the video game industry over the last bunch of years, and a lot of the stuff you guys are hitting with problems, the exact same problems that they kind of solve. Yeah, so unfortunately, there's never any video game developers.
Luckily, there were some people that helped the video game developers first by making up mathematical models around this stuff in the 70s. These are all distributed systems problems. Back building distributed systems, all of this stuff has been taken care of, and the video game guys came in a lot. But way back in the 70s, there's actually 2 or 3 mathematical models that actually describe all of this.
All of 20 horse stuff.
Similar to like relational algebra, there's actually formalized mathematical models to express what we're talking about. What I was originally raising my hand for, though, was I've actually traced these ideas going back for writing a book. And I managed to get them to Sumeria and Mesopotamia. It's an entire way of thinking. Well, actually, back then they used to use clay tablets, and they would write on a clay tablet, and then they would put a stamp on a clay tablet, let it dry in the sun, so that way they would prove it was immutable. And then you would use multiple clay tablets, and by playing back your clay tablets, you would actually come to some idea of base numbers. But I just wanted to add that, because it's not even 50 years ago. I mean, this goes back thousands of years.
You just reminded me of Udi Dahan's got a talk where he's probably got many talks actually where he goes about how things were done back in the 70s where the papers that people would shuffle around and maybe mail around, that was the record of truth. Not what the computer had. Like, the computer was something you would input the truth into after the fact. So in addition to Greg's videos on CQRS and event sourcing, movies are good. And Roman Scott?
So Christian Erickson asked a question. Where's Christian?
I'm here, but I didn't ask a question very much.
Oh, you must be double clicking on stuff.
Yeah, the other one was Simon.
Oh, that's my bad. I was just seeing if it would work.
It did. Okay. So that was the other thing. We haven't gotten to. We're doing this in the last minute. So the UI for actually seeing the questions and overlaying. This slide has a question for like putting a little red star, and this slide has 20 questions. We never got to it. So curl gives you the records and the IDs of the slides, so we don't know what you asked about it. Anyone else?
No, that's it.
Okay.
You mentioned some of the good things about it. What are some of the pitfalls or issues you run into, and when would you not want to use this model?
Okay, the simple one, thinking specifically of what we just did here with the slideshow, if you're not doing anything fancy, a slideshow is just like navigating back and forth in hyperlinks. If you're just doing a path through a pre-existing, unchanging space, space and slides, and your path through them, why bother with any of this? Hyperlinks work just fine. If you want to get fancy and hand wave and show off techniques, yeah, then you can get an argument for doing it. But I would say anything where you're tempted to start going down one of the MD whatever framework paths, it's worthwhile thinking about this. Yeah.
I actually did click the question button, so you missed one.
Okay.
When you were talking about generative testing, you talked about testing your entire function space for a function, and you could like randomly sample inputs through there. But how are you going to validate your output without writing your function again?
You basically sort properties, and this is where you can get easily get into the dynamic versus strong typing discussion there. But you're asserting properties about the inputs and the outputs, and strong type people will say, well, that's what type systems do. But the examples that Yuri, or the system that Yuri was talking about, you basically define properties, invariants that you expect on the inputs and the outputs, primarily on the outputs. And you just sample enough of the inputs until you find
everything works in a reasonable amount of time, or oops, some sub-range of the input space fails.
Other thing you need to point out is that you're testing properties of code rather than specific assertions of, say, this email equal to this test email that I'm checking out. Like you actually checking properties like in the simplest of
logical properties.
Yeah, logical properties, like in sorting. If you do a sort algorithm on a list, the result list has the same length. Kind of those properties. We always use